So in the vision part of the class, what you did is you looked through the ophthalmoscope. Hopefully some of you managed to see a blood vessel. If you did, well done. That's actually quite a great achievement. And we looked at reflexes. And I asked you, why is it that when the subject is looking up close, their pupils constrict, and what's the benefit of the consensual light reflex? So to try and understand that, what I've done here is do a little drawing. This is meant to be your eye, so we've got the cornea. At the back here, we've got retina. We have the lens. And for an object to come into focus, the light rays that are leaving, say, the tip of this arrow, need to be focused back at the same point on the retina. Okay, and for an object that's quite far away, the light doesn't need to be bent very much. Okay, it's got not much what we call divergence of those light rays. If we consider it now for this close-up object, we've got to bend the light quite steeply, much bigger angle here than there, and that's tricky for it to happen. So what often happens is that we actually can't bend it in time, and so instead of being a dot, we end up with what we call a blur circle on the retina. And that's particularly a problem when you're up close because that light is diverging more sharply. One way to deal with that is, instead of having a big pupil to let all of the light in, if you make the pupils smaller, so you only have a small pupil, then basically all of the light that's coming through has to be more closely aligned. We've only got a difference between here and here, and so we can reduce the size of that blur circle by making our pupil smaller. You may have done this at school by making what's called a pinhole camera, or if you're short-sighted like myself, you can actually see things that are far away by making a little pinhole. If you just get your fingers and you look through the gap, you can see things sharply. And even if you have normal vision, when I come up very close to the board, it all gets fuzzy. Again, if I make a little pinhole, you can put it in a sheet of paper, that's better, or you can just look through your fingers. I can actually keep that image sharp right up close to the screen. So the reason the pupils are constricting is not because you want to make it darker, it's because you want to reject that fuzzy, out of focus information and produce a sharper image. Okay, so we get constriction of the pupils when we're working up close. The two eyes work together because they're converging. So when we're working close, there are three things happening. We have convergence, which is the fact that the two eyes are looking inwards. So there's your eyes. You're converging at a point instead of looking straight out. You have accommodation, which means that your lens, instead of being skinny, becomes fat so that it's better at bending the light. And then the third thing we have is this pupillary constriction. And the technical term for what it does is it actually increases our depth of focus. So it's one thing to have things sharp, but when I'm working up close, I might be able to have my thumb in focus, but this finger isn't in focus. What I want is to have as much in focus as possible, and the pinhole effect expands that range where multiple things are in focus.